Good morning, my dear students, grade 5. My heroes, how are you today? Today, 23 April 2020. Open your book page number 877. Write the date of today. We are going today to reteach topic 16. So open your book and be ready with your pencil. Write the date of today at the top of the page, 877. Okay. In our session today, we are going to revise set A and set B. Set A covers a part inside your book from page 851 to 856. This part represents classified triangles. And set B cover another part inside your book from page 857 to 862, classified quadrilaterals. So open your book today, 877, and be ready with me in set A. If you have a question or something difficult in this part, you have to prepare it outside the book, and at the end of the lesson, if you need help, you can raise your hand when we open the participation to share your question and your confusion point. Okay, my dear? So pay more attention and concentrate on the following, please. As we said, we are going to revise the triangle and how to classify triangles. Triangle is a polygon with 3 sides and 3 angles. Triangles can be classified by, yes, 2 types: the length of their sides and the measure of their angles. Don't forget that. You can divide or make categories for triangles according to the side length and also to the measure of their angles. Okay, so we can start with equilateral triangle, which all sides are equal in length. So the first type, according to the length side, is equilateral triangle, and this one according to the sides of length. We have here in this case, all sides are equal in length. So the name of the triangle will be equilateral triangle. Equilateral triangle, all the sides are the same or equal in length. The second type, according to the side lengths, is isosceles triangle. Isosceles triangle has 2 equal sides in length, or 2 same sides in length, at least 2. It must be, to say isosceles triangle, you must at least has 2 triangles equal in side, or sorry, equal in length. 2 sides are equal in length in isosceles triangle. Okay, scalene triangle. This is the third type according to the side lengths. Scalene triangle. When we have a scalene triangle, we have 0 sides or no sides are equal in length or in the same length. 0 sides equal in length is scalene triangle. So we have 3 types according to the side lengths in triangles. The first one here is equilateral triangle, all the sides are equal in length. Isosceles triangles, at least 2 sides are equal in length. Scalene triangles with no sides are equal in length, or 0 sides are equal in length. Let's move to the second section of categories for triangles according to the measure of their angles. The measure of their angles. The first one here, we have a triangle with just one right angle inside. So we can determine the type of it as right angled triangle, right angled triangle. So it has just one right angle inside. So I can determine that type here according to the measure of angles as right angled triangle. The second type here, acute triangle. Acute triangle. Acute triangle has three angles or acute angles. Three angles inside, all of them is less than 90. All the three angle or the three interior angle less than 90. Sure, each one, not the summation of the three interior angles, because the summation of the three interior angle of any triangle equal 180. So we have here acute triangle which contain three angles inside or acute angle. That means each one less than 90 degree. The third one, obtuse angle triangle. Obtuse angle triangle. One angle is inside is obtuse angle here. So we can say the sum of the three interior angle of any triangle equal 180 is a sum. If you add the three interior angles, their summation will be 180. But sure, you have to determine the type of the triangle according to the measure of their angles by focus each one and see. There is no more than one right angle inside any triangle. To say right angle triangle, just one right inside. Also the same in obtuse angle, just one obtuse. There is no triangle in the world that contains two obtuse angles. Just one inside for obtuse and right. For acute angles, sure you will have three because the summation of the three interior acute angles will be 180, so you can form easily the triangle. And this is the triangle categories that we have in grade 5. So let's move and start in page 877. After listening for the small revisions that I mentioned about the classifying triangles, how to divide it according to the length of their sides or the measure of their angles. Let's read set A and try to understand what we are going to do. Classify the triangle by the measure of each angle and the length of each side. It's clear for you now. Three types here and three types here. Three types for side lenses and three types for measure of angles. Since one of angles is right, this is right triangle. Since two sides are the same length, this is an isosceles triangle. Okay, that's easy, Mr. Elite. Okay, so the triangle in front of you, I can say it's a right isosceles triangle. Right for angles of measure, isosceles for the side lengths. It is a right isosceles triangle. Right isosceles triangle in front of you. This one we have to determine or classify it according to the last line here. Can read it and say it is right isosceles triangle. Why? Why we said that? Because we have just one right angle inside and we have also two sides are equal in length. Okay. So let's see the first questions here, and you will find on the left hand side the conclusion of the categories of triangles according to sides or according to angles to help you to determine and answer the following question. Remember, that the right obtuse and acute describe the angles of triangle. Equilateral, scalene, and isosceles describe the side of triangle. According to the given data here, or the given points here, you will find, as I told you, a conclusion for all types, for side lenses or for the angles. So let's start the first question here. Say, classify each triangle by the measure of its angles and the length of its sides. Okay, number one, we have a triangle, the orange triangle here. By seeing, you will find three interior angle, each one equal 60 degree, less than 90. It means we have three acute angle inside. Also, in the orange triangle, you will observe that we have three sides are equal in length. So I can make it, I can classify it in a form of acute equilateral triangle. Why acute? Because we have three angles less than 90. Why equilateral? Because we have three sides are equal in length. Okay, my dear. So the first one will be acute and equilateral triangle. Let's see the second one, the green triangle. The green one here, we have three sides. Sure, they are not equal in length because the first one equal 3 inches, the second one here 4 inches, and the third equal 5 inches. This small square inside in the corner here represents 190-degree angle or one right angle inside. So that I can classify the green triangle in two types. Right angled triangle. Also, because we have zero sides are equal in length, I can call it scalene triangle. So my answer here will be right scalene triangle for the green one, right scalene triangle. In number 3, also we have green one here with two sides, both of them equal 8 centimeter. So we have two sides are equal in length, just two, or at least two sides are equal in length. This is for isosceles. Yes, you are all, I trust you all understanding and save this lesson. Two sides are equal in length, both of them equal 8 centimeter. One obtuse angle inside, one obtuse more than 90 inside. So it will be 105. So I can classify this triangle as, yes, obtuse isosceles triangle. Obtuse isosceles triangle. This is the type of number 3. Okay, carry the answer. Don't forget writing the date of today at the top of the page. In number 4, the blue triangle containing two sides are equal in length. Oh, no. Zero sides are equal in length. I'm confused here. 16.4 not equal 16 centimeter. 16.4 is more than in length. Okay. And the third one equal 10. So we have here zero sides are equal in length. So 16.4, 16, and 10 not related to each other, not equal in length. Also, inside here, we have 70-degree, yes, corner angle at the bottom here, and 75. Both of them are acute angles. Sure, the third one will be acute also. So we have three acute angles inside. It will be acute scalene triangle. Okay, copy the answer and be ready to set P. We're going to finish today more quickly than any time to listen for your confusion and your difficult. If you need help, when we said this is the end of our session, just raise your hand. When you hear Mr. Walid say this is the end of our session, just raise your hand at the end of our session. I will make it easy for you, everything. Okay. Set B, categories of quadrilateral are classified by their properties. As we mentioned at first, this is the second part in our lesson, is how to classify quadrilaterals, and let's listen about the categories of quadrilaterals that we have in grade 5. The first shape in front of you is called trapezoid, has one pair of parallel sides. This is the properties of trapezoid. You have to save and memorize that trapezoid has just one pair of parallel sides. Okay. What about the second shape? Look at the second shape here. Yes. It's called parallelogram. Parallelogram. Parallelogram has two pairs of opposite sides parallel and equal also in length. So when we compare trapezoid and parallelogram, what can we deduce from this competition or this comparison? We will find that the difference between trapezoid and parallelogram, that parallelogram has two pairs of opposite side or two opposite parallel sides, but trapezoid has just one pair. In parallelogram, each two corresponding sides are equal in length. This is a must in parallelogram, but in trapezoid, there is no sides are equal in length. So we have to differentiate between the two shapes, and don't forget to do that each time. Also, don't forget the properties of each shape. Let's see the third one here, a rectangle. What do you know about rectangle? Rectangle has four right angles inside. Also, each side are equally length and parallel, so I can consider the rectangle as a parallelogram or a special case of parallelogram. Okay, the fourth shape here is rhombus. The rhombus has all sides in the same length. All sides in the same length. I can consider that rhombus, the square, a special case of rhombus containing four right angles, but I can't consider the rhombus as a square because the difference between them will be in the measure of angles. There is 90 degree inside the rhombus. But when we find that, we can call it is a square, not rhombus. Sure, both of square and rhombus, all the sides are equal in length, but the only one difference here between them is the measure of the interior angle for square and rhombus. So let's see the first shape here. It will be a square. The square has all sides in the same length. You can say all sides are equal in length. A square has four right angles. A square has four right angles. This is about the square. Okay. This slide is the categories of quadrilaterals that are classified by their properties. The slide will help you, if you save and memorize it, to determine the shape in front of you. Also, you can make a comparison or a competition between the shapes. Let's go set B, read lesson. Quadrilaterals are classified by their properties. Number one, as we said, a trapezoid. Trapezoid has one pair of parallel sides. Second one is a parallelogram has two pairs of equal parallel sides. Okay. Third one, a rectangle is a parallelogram with four right angles. A rhombus is a parallelogram with four equal sides. A square is a parallelogram with a right angles and four equal sides. Okay. Let's remember that some quadrilaterals can be identified by more than one name. According to what? According to the given properties in front of you, you can determine the name of the polygon in front of you. So I can give more than one name for just one shape, according to the given properties that I saved and memorized. For example, the blue one in question number one, the blue shape in question number one, we have two pairs of parallel equal sides. It means each two opposite sides are equal in length and both of them are parallel. Each two corresponding sides are parallel also. So directly from seeing, I can say it rectangle. But here is same properties between the rectangle and parallelogram. And because of this polygon formed of four sides, I can call it quadrilateral also. So we have here three names: quadrilateral, parallelogram, and rectangle. This is for shape number one in page 877. Okay. Move to question number two. The green shape. Formed of four sides. Four sides is called in Latin language quad. Quad means four or equal four. The word quad, Latin word that means number four. So we have here polygon formed of four sides, closed shape formed of four sides, just only four sides. You can say quadrilateral. All sides seems to be equal in length. So this is a square. No, this is not a square because all sides are equal in length, sure, but we haven't 90-degree inside. So I can say this is rhombus. You can find some properties are the same between rhombus and parallelogram. Each two opposite sides are equal in length and two pairs of parallel sides. So I can say it is also parallelogram. So we have here quadrilateral, parallelogram, and rhombus. The third blue shape, yes, quadrilateral and trapezoid. Quadrilateral, why? Because it formed of four sides. Trapezoid, because it has just one pair of parallel sides. Okay, I give you the reason for each shape, why we called these names for each shape given. I'm not called them from my mind. No, according to the given properties for every shape, I can say the name of the shape. The last one, the yellow shape, number four. We have four sides, so we can say quadrilateral. Each of them or two pairs of parallel sides, we can say parallelogram. four angles inside, we can say for right angles inside, we can name it as rhombus and square. Only for right angles inside, just only for that, I can say it is a rectangle also. So we have here four names. Someone say, Mr. Reed, it is not a rectangle. I can respond for him and say, here I can consider the square as a special case of rectangle, but I can't consider the rectangle as a square. Okay? Okay. So there is a flexibility here to consider the square as a special case of rectangle, but there is no flexibility to consider the rectangle as a square. Okay? Okay. Now this is the end of my session here. Thanks all for watching. Thanks for paying attention for me. That is the end of our session. Thanks for watching. See you the next week, inshallah.